In this problem, Cassie is showing that the cube root of 2 plus 11 square root of negative 1 is equal to 2 plus I. First, she cubed both sides to cancel out the cube root. Then, she FOILed out 2 plus I cubed. After FOILing out 2 plus I cubed, she inserted negative square root of negative 1 for I cubed, negative 1 for I squared, and square root of negative 1 for I. In this problem, Cassie is showing that the cube root of 2 minus 11 square root of negative 1 is equal to 2 minus I. As in the problem before, she cubed both sides to cancel out the cube root. Then, she FOILed out 2 minus I cubed. After FOILing out 2 minus I cubed, she again inserted negative square root of negative 1 for I cubed, negative 1 for I squared, and square root of negative 1 for I. Here, Cassie used the answers to the problems above to prove that Cardano's formula works given the equation x cubed equals 15x plus 4. This is people's reaction to square root of negative 1. But no one gives this reaction to 1/3. Or 0.999 repeated. Why does this happen? Well, 1/3 and 0.999 repeated are accepted as normal in math, while square root of negative 1 has never been accepted. We have proven that square root of negative 1 and imaginary numbers in general are more natural than we seem to believe. The difference between the Cartesian plane and the Argand plane is that on the Cartesian plane you are graphing an equation where you can find both parts of a point. On the Argand plane, one part of the point might be found, but the imaginary number might not be found. Going off of the Argand plane, we decided to graph point z. Then we graphed z squared, z cubed, z to the 4th, and z to the 5th. To find these points, we added the arguments and multiplied the magnitudes. We then connected the points on the graph and realized that it made a spiral. With the equation z cubed minus 1 equals 0, we are trying to find three distinct complex solutions that make this equation true. The first solution is 1, because the magnitude is 1 and the argument is 0 degrees. The second solution is 1 times e to the I times 120 degrees, where the magnitude is 1 and the argument is 120 degrees. The third solution is 1 times e to the I times 240 degrees, where the magnitude is 1 and the argument is 240 degrees. All of these make it so z equals 1, which makes z cubed minus 1 equals 0 true. All of these investigations are important because they help broaden our understanding of complex and real numbers. In the beginning, we believed that the square root of -1 was truly imaginary. After working through these investigations and seeing imaginary numbers in relation to real numbers, we now realize that imaginary numbers are just as real as any number.